that. Yeah, so moving past that, the next is the batch calls. Not a fan of how 1155 asks you to implement batch calls in their way. I think in particular this is important because people will do batch calls in very strange ways, right? Like maybe somebody wants to do it the standard way of just throwing a bunch of arrays at it. Some people may want to use like structs, maybe like an array of structs, right? Um, or in some cases, there are people that like to pack call data as much as possible, because there's some gas overhead with larger call data. So maybe they want to pack that a little bit tighter and then do a batch call like that, right? There's a lot of things that you can do to optimize there, and 1155 kind of blocks that. So that's the next one, removing the batch calls from the system. And finally, there is one more. Just a second. Let me pull it up. Right, and then the other is the callback system, right? So in 1155, the only way that the specification says to transfer tokens is through safe transfer and safe transfer from. First of all, prefixing a name with safe is an anti-pattern because it actually doesn't make it safe, and I would argue that it's unsafe because within the control flow of this token, you're actually making an external call to untrusted code, and that's a big problem, right? There's like you're handing the execution flow to some other contract that's inherently unsafe. So removing that, and then also removing this sort of foot gun where if you have a smart wallet and you just so happen to forget to implement the 1155 hook, you can't receive 1155 tokens, and that's a big problem. So yeah, basically got all of that, remove all of that, and then let's just get down to the basics of this, right? So I'm just going to step through the definitions real quick. So infinite. No, that's okay. For now, I'm just going to scroll through this markdown document. So if you want to just scroll along with that, that'll be fine. So yeah, in the specification section, we have a few definitions. Infinite, usually in the context of like infinite approval. This basically just means the maximum value for UINT 256. So that's 2 to the 256 minus 1. Caller is, of course, the message sender, the person who created the current execution context. The spender is an account that transfers tokens on behalf of another account, right? So this is the person who operates with an allowance. And then operator is an account that has unlimited transfer permissions on all token IDs for another account. So think of spender and operator like think of an operator as a spender with infinite transfer permissions, right? So it's just like a level of authority above spender for a given account. And so stepping through, first we have a total supply method. And so this gives you the total supply for a given token ID. I actually don't think 1155 includes this, but I think it's important because you need to know how many of these things exist without having to index events. Next is going to be balance of. And so this is a balance of that actually takes an address as well as an ID and returns the balance of that token ID for that address. I think this is one-to-one with 1155. Next up, we have allowance. So this is, sort of how the allowance system works with like ERC20 with an additional parameter. So you have an owner, a spender, and an ID. And so the amount that you get out of this is the allowance that the spender has to transfer of the given token ID on the owner's behalf. Next up, we have the transfer function. So this thing, it transfers an amount of the token ID from the caller to the receiver. And I have a couple conditions here, right? It must revert when caller's balance is insufficient. It must log the transfer event. It should decrease the caller's balance for the token ID by the amount, and it should increase the receiver's balance for the token ID by the amount. Now I'm using the word should here because this actually will explicitly allow for fee on transfer tokens for like fungible tokens, right? So let's say one of these has in tokens and they want a 10% fee on all transfers, right? They could just implement that and it's still within spec. Next up, we have transfer from. This behaves in a similar way, but you can specify the sender to transfer it from. Of course, if you aren't, if the caller is not the sender, then we need to check for some kind of permission, right? So stepping through these conditions here, it must revert when the caller is neither an operator for the spender, nor do they have sufficient allowance to move this amount of the token ID from the sender. That's pretty standard approval / operator behavior. It must revert when the caller's balance for the token ID is insufficient. It must log the transfer event. It must decrease the caller's allowance for the sender if the allowance is not infinite. Now, there's a little bit of a gotcha here. I'm going to add a condition here soon, but basically to say that however much the sender's balance decreases by, that's how much the allowance should decrease by, right? So if you have something like a fee on transfer token and only a certain number of tokens are transferred from the sender, that's how much the allowance should drop by, however much it decreases. So stepping through, what's that? In 1155, no, because everything is just infinite approval, right? And the 52, what was it? 5216. I think they do have a little something in there to allow you to decrease that allowance. But uh, yeah. So we should decrease the sender's balance by for the token ID by the amount. Do the inverse for the receiver. Now it should not decrease the caller's allowance if the allowance is infinite, right? And it should not decrease the caller's allowance for the token ID if the sender is an operator. So if you give, let's say an account, let's call it Alice, right? If you give Alice, let's say 10 tokens of approval, and you set Alice as an operator, the operator should take precedence. So Alice can transfer as an operator without decreasing that allowance, right? Because you already have infinite approval anyway.
What is the benefit of having an operator?
Well, the benefit of having the operator is the same as with 1155. You basically just give full and total permission to the operator to transfer any tokens on your behalf. So if you're giving them full permission anyway, then you shouldn't decrease the allowance. Now, I did explicitly say should not, because maybe somebody has a preference for this where they say that they want the allowance to decrease despite whether they're an operator or not, right?
Okay.
They're two independent authentication schemes, but it's just a matter of deciding which one takes precedence. So going to the next, we have approve. This behaves pretty much as you'd expect. It approves an amount of units of a token ID that a spender is permitted to transfer on behalf of the caller. It must set the allowance of the spender of the token ID for the caller to the amount, right? So basically, however much you say, that's how much it should be set to. We're not doing increasing or decreasing, just explicit setting. And it must log the approval event. Next up, we have set operator. And so this is the second permission scheme here, right? Where we say it sets the spender as an operator, granting unlimited transfer permissions for any token ID for the caller. So this is the same as 1155. It must set the operator status to the approved value. So you can set true or false, and it must toggle that. And then it must log the operator set event. So next up, we have events. The transfer function, again, pretty standard stuff. The sender has transferred an amount of a token ID to a receiver. It must be logged. When a transfer happens, it should be logged with the sender address as a 0 address when it's minted, and it should be logged with the receiver address as a 0 address when it's burned. Still pretty standard behavior there. Operator set. This must be logged when the operator status is set, and it may be logged when the operator status is set to the same status that it was before the current call. So if you set somebody to be the operator and it's set as true, right? If you go back and you set it again to true, right? There's not actually a state change happening. So in general, I think the easier and more gas efficient branchless way would just to say log it every time. But that's not required, right? Maybe somebody wants some use case where if it is set to the same thing, then they consider it to not be a state change, so they don't need a log, right? So that's totally up to the implementer there. That's why we say may.
What happens if
and then finally we have.
Sorry, Jay. What happens if the operator gets compromised?
Well, this is the same as with anything else, right? You can have some kind of revoke.cache type interface that allows you to set the operator to or set the operator to no longer having authorization, right? So it sets it it's got a Boolean value in there, so you can set it explicitly to true or false.
Awesome.
And this also allows you to not have to be aware of the state information, right? You don't have to read from storage to see what the status is to toggle it. In this case, you can just store it, so you're saving an S load there. And then finally, we have the approval event, which again, pretty standard. The owner has approved a spender to transfer an amount of a token ID to be transferred on the owner's behalf. It must be logged when the approval is set by the owner, and it may be logged when the approval is decreased by the transfer from function. I don't know of anybody that really does that in the wild, but that is a thing that maybe somebody would want to do in the future. So we allow that. Okay. We allow that per the spec.
Let me take a
look. If you want to check the reference implementation, what's up?
I will take a look at that and see the reference implementation here. Okay.
Yeah. So which one is this? Yeah, this is the contract implementation. So we can just like step through and just see pretty briefly. Now I've defined 2 errors here, so you don't actually have to have these. This isn't part of the spec, but
Okay.
maybe I'll add it. I'm not really sure. I think the exact error message shouldn't be a part of the standard, but that's kind of up for discussion there. And after that, we have our 3 events: transfer, operator, set, and approval. Below that, we have some public state variables. That's our total supply, balance of, allowance, and is operator. Next up, we have transfer. So it checks the balance, makes sure it's sufficient, decreases the sender, increases the receiver, logs the transfer event. Same thing for transfer from, but we do have a little condition in here that if the sender is not the message sender and it's not an operator, then we have to check the allowance, ensure that it's sufficient. If it's not, we revert, and then we decrease the allowance. Right. Now, in this case, I'm not actually checking to see if it has a max approval, but again, it's just a reference implementation, and that was just a suggestion in the spec. And then after that, we'll see the insufficient balance check, make sure that it's good, decrease the sender, increase the receiver, log the transfer function. The approve function, you set the allowance directly, you log the approval event, and then for set operator, you can set the operator status, and you can log that event there.
It's pretty clean.
This also has tests implemented, so if you want
Let's take a
to
look.
clone this locally and run forge tests, it's all good to go.
Let's do it right now.
Yeah, it's going to be HTTPS : / Oh, do you want to? There you go. Easy peasy. Oh, you copy paste a little bit too much there.
So, like, what are the applications of the multi-token standard? What scenarios can they be used?
Yeah, so this is meant to be a drop-in replacement for ERC 1155. So everything 1155 can do, this standard can do. Obviously, it doesn't have the batches built into the standard itself, but that can always be implemented by another contract. But yeah, so it can be used for, like, obviously NFTs. It can be used for semi-fungible and fungible tokens. It can be used to manage multiple tokens under the same contract address, which of course carries implications for governance, DeFi, NFT fractionalization, whatever you're looking for. By the way, I'm getting some feedback through you.
Can I throw in a question there?
Sure.
What was the main motivation for this? Was it like the missing allowance from 1155 or?
It wasn't just the missing allowance. It was the missing allowance, the specification for batch calls built in. It was the unnecessary callbacks. It was the safe transfer and safe transfer from naming patterns. Actually, I think that covers all of it.
Is this actually in EIP or not yet?
Not yet. I kind of just drafted it this morning. It came from a conversation talking about some of the problems with ERC 1155, and yeah, I figured since there's nothing else out there that's really specifying an alternative, I'd put the spec out there and kind of see how people like it, and if it's something that people want to something that people want to see in production, then we can absolutely make it, you know, an ERC, and yeah, then push for adoption for it.
Would you include token URIs, or is that not part of the spec?
Yeah, so that'll be included with sort of extension to the specification. So it goes hand in hand with the way that ERC 721 and ERC 1155 do it, where the core specification doesn't include anything about token URI name or symbol, but that can always be added, you know, with an extension. So it'll probably be something along the lines of, you know, ERC, whatever the number is, metadata, right? And then the spec will probably just follow 1155 and 721 just for the sake of compatibility. Yeah, no need to try and innovate on the metadata front. The biggest thing that we're looking to innovate on here is, you know, the actual design of the contract.
I like it.
Thank you.
So can I have a chain of operators? No, right? Like, and I don't. The operator itself. Is that?
What do you mean?
I mean, like, so I'm setting an operator to control all my assets, right? Can this operator also have an operator?
Not the transfer. Like, you can't have an operator that transfers on another operator's accounts, right? So if let's say Alice has tokens and she approves Bob as an operator, and then Bob approves Charlie as an operator, Charlie cannot transfer Alice's tokens. Charlie can only transfer Bob's tokens.
Awesome. And have you made any tests with gas to see if that's, you know, cheaper than the current implementation?
I mean, this isn't really intended to be an improvement on gas. Also, this reference implementation here is actually more optimizing for readability than gas efficiency. Like, there's a lot of like really low hanging fruit to optimize here, but the biggest thing that I'm you know, shooting for with this reference impl is just to make it, yeah, make it painfully obvious what everything is doing in each step. But yeah, there will obviously be more optimized, optimized implementation. So if this is something that ends up, you know, getting some traction, we can always do something pretty absurd with Soul Lady, like you know, like Vectorize likes to do.
Very nice. So when you're gonna be sending the EIP, bro?
What's that?
When you're gonna be sending the EIP?
We'll see. We'll see how it goes. So far, I haven't really gotten much feedback. You know, I've spoken to a Seaport dev and a couple other devs that are like pretty close with an FT dev that, you know, they seem to like it so far. But obviously they haven't had a whole lot of time to dig through the specs, so I don't know. We'll see how it goes, and if it goes really well, then we'll put an ERC up.
Really nice, really nice. Cool job, bro.
Yeah.
Amazing. Anybody has more questions to Jay?
Yeah, thank you. Oh, I did just see a comment over here in the voice chat. Yeah, so if you're already working on an ERC 1155, go ahead and just do that. You don't have to, you know, start working on this before a formal specification is up. This stuff is still pretty rough draft, but yeah, if it's something that you're interested in the future, feel free. And of course, I'm always happy to help out with something like that.
You know what would be fun if we did the tests ourselves, you know, so we can get this and try ourselves, run everything. That would be pretty cool. If you guys are down, we can do that. Let me take a look at the way the test is written here. Sweet, man. How long to code this, Jay? 3 hours? Even less, right?
Yeah, about 2 hours. Yeah.
Yeah.
Yeah. The basic format here is just, you know, precondition, execute the thing, then post condition if you end up adding some tests to this.
And what about the extensions? Have you thought about something already? Like the interfaces, the compatibility, you know?
Yeah, so I mean, the only thing that would really be required to get this thing compatible with other things is just to have, you know, common marketplaces, you know, implement the right functions for it, right? So like with Seaport, it's just a matter of adding like a transfer helper for the specific interface, which I mean that's pretty it's pretty low hanging fruit, right? Like it's not super complicated, especially since the system is meant to be pretty minimal. But yeah,
So Jay wakes up one day and say, "Hey, I'm gonna change the way ERC 1155 works," and it's gonna make a lot of sense. Really nice, bro. Beautiful morning.
yeah. Thank you.
Yo, I guess this is it. You guys wanna talk anything else? I guess no. Thank you, Jay.
Sweet. Thanks for having me. And of
problem.
course, if you guys have feedback, you found any issues, anything like that, feel free to DM me here. Open up an issue on GitHub. Whatever works.
Thank you, bro. See ya.
Take care, guys.